Hey, this is Don from Padlock Technologies again with another video. Before I even start, here's the shirt that I was talking about in the last video, talking about, I think it was the PDR video. You can't protect what you can't or what you don't inspect. So that means if you're not inspecting the traffic, you can't protect yourself against the bad guys. So again, another nerd level 9,000 shirt. I got a bunch of these, so you'll just see them a bunch of videos. But today, we're going to talk about the secret troubleshooting module or another technique to troubleshoot data plane traffic on the FTD. Now, most people do not know about this certain platform or this feature in the FTD because a lot of people they don't really teach this, right? They don't teach it in a lot of the courses that I've seen. Um, and you have to basically read the literature on the FTD platform, like the nuts and bolts and, traffic flow, how everything works and how to kind of troubleshoot it like a tech engineer, so to speak, um, for you to even remotely find this feature. Now, let's go over and let's review some of the ways that you can do some troubleshooting here. So most of the time you can do a packet tracer, right? Or you can do a packet capture. Now, those things are going to say the packet tracer is going to show you, going through how the packet goes through everything in terms of, natting and what role did it hit and what interface did it go out. So, packet tracers are good to see if the role was allowed. Packet capture is to see that the traffic is actually flowing through an interface. Still layer three stuff, right? Layer one, two, three stuff. So it's showing, hey, I see traffic going out, I see traffic coming back, right? And with packet captures, you pretty much got a packet capture on the same side. So they got to do it on the internal side and the external side as well to make sure you get a bi-directional communication. But what I rarely seen people use is the firewall debug engine. So what is the firewall debug engine? The firewall debug engine is basically another feature in the firewall that you can use to actually see what rule your actual traffic hit. Now, this is going to go through your entire ACP and it will show you no match, no match, no match, no match, no match, no match. And then when it finally hits a match, it will say it hit the match here, right? Here's the rule that it hit. So you can kind of see what rule it gets hit first, like as that traffic is going through. Is it actually hitting the rule that I created or did it hit some rule above it that I didn't even know it was hitting, right? So this is what can help you. Now you can still do packet tracers to look at that information, but you're gonna have to go scroll through the packet tracer. This is kind of going to tell you immediately if it's a no match, no match, no match, and then there's a match. Now, with this being said, this is CPU intensive, so if you use this, you could end up spiking your console login or your console. So you got to do this sparingly. I wouldn't do this all the time in terms of troubleshooting, but I know a lot of tech engineers don't even use this method as well. But they usually they'll put me on mute and then I'll say, hey, just use the firewall debug engine, and they'll say, oh yeah, I forgot about that. So how do you get there? Well, there's one way, there's one only way to get there, and it's similar to how you get to the Lena interface of the FTD. And if you don't know what the Lena interface is, that is the ASA part of the FTD. So there's two modules there. There's the Lena module, and then there's the Firepower Services module, right? And the way traffic goes through, think of the Lena module as layer 1 to 3, and then the Firepower Services module is layer 4 through 7. Now, if you want me to do a video about how traffic actually moves through the firewall, put it in the comment below and I'll make that video. That is probably the first thing you actually need to learn about the Firepower device, because once you know how traffic actually moves through the firewall, you can kind of tell where things are broken from a troubleshooting standpoint. Because, hey, if I'm getting through, you know, the Lena interface, it may be getting blocked somewhere in the Firepower Services engine, and then you have to worry about, hey, is it security intelligence? Now there's two security intelligence modules in the Firepower Services, or checks in the Firepower Services module. There's the DNS one and there's the IP one. So it could be getting through one and getting blocked by the others. Like, this is the stuff that you need to know in terms of troubleshooting the FTD. So if you want me to make that video about how traffic actually moves through the Firepower Services or the firepower threat defense device, then just put it in the comments and I'll make the video. So what we have to do, there is a command called system support firewall engine debug. So we're going to do this here, and you're going to see exactly what we're going to do. And I'm actually going to show you a ping. We're going to match ping, and then you're going to see the actual results. So let's go into it. System support firewall engine debug. And then when you get to firewall engine debug, this does take a while to kick in, but it will tell you the warning that this is very CPU intensive. So be careful using this. Okay. It's just like flex configs. It'll warn you, hey, if you don't know what you're doing with flex configs, don't use it, because if you break your FTD, this is on you. This is just telling you, hey, this is CPU intensive. So if you turn this on and you do it wrong, or you match the wrong traffic, you'll just have a screen of white noise going through your FTD, and it's very hard to turn off. So IP protocol, we are going to look for ICMP. Now the client address, I got a client over here. I'm going to just do IP config just to get the address. And what's this? 1611. So we're going to do 192. Get back here. 192, 168, 16.11. Server port. Our server address, don't care about that. I should have did, I don't care about it. Because I should have specified 1.1.1.1, but who cares? I'm just gonna say, I'm just gonna match any ping. So when I go down to ping, let's say 8.8.8.8, as you can see, this is what the firewall debug engine does. Now, if we look at it, it goes through my entire rule set. So no match on rule order one, right? Now let's go into the firepower so we can match this here so you can see the same thing. So we're gonna go, what was this on H firewall? So let's go into our access control policy so you can see us going right through here. I think it was the HQ INET firewall that I have here. And since this is on a child policy, we're talking about this stuff here. All right, so no match on rule one, Office 365. That's that rule. No match on web conference. That's that rule. No match on video conference. That's that rule. No match on block URL or block apps. 4 and 5. And then 6, match rule 6, internet rule, action allowed. So what that tells me is it didn't match the first 5 rules of my ACP, but it matched my internet rule because I am allowing, if we go down to here, I'm allowing ICMP in my rule, right? So I'm allowing that. I'm not matching any of my block apps or anything like that. So as you can see, we're matching rule order 6. So that tells me that I can instantly go to rule number 6 and see, oh, okay, I'm matching that rule. Now let's say it was a piece of traffic that I had a rule for in rule number 6, but for some odd reason, it was hitting rule number 2. Well, you would see exactly in the firewall debug engine, hey, it's hitting rule number 2. And what's the action? It's allowed there in the action. So this is how you can find real fast, as well as using packet tracer. I'm not going to down packet tracer, but this is how you can find real fast, hey, I'm matching a rule that it shouldn't be matching. Like case in point, I got a deny rule somewhere in my ACP, but I'm hitting a permit rule because it's matching the traffic. Well, you'll see instantly in here, hey, I'm matching this rule here and it should be matching this rule. But again, this is CPU intensive, so be careful with this, okay? But to avoid those problems, have proper rule management, right? Don't just have comments in your rules. Your comments should always match some kind of service or change request. and that change request should have a numerical value on it. So, and the date that you put the rule in there. So it should be, hey, description of the rule, allow whatever to this server, whatever server, the date the rule was put in, the change request that this correlates to. So if anybody asks, you get audited, hey, what is this rule about and why did you put it in here? You can look at the comments and say, oh, this rule is supposed to allow this type of traffic. We did it on this day, and here's the change request that was approved in my CAD process for this rule to be here. And then, when that rule is no longer warranted, I always say, disable first, see who screams. No one screams, delete. So this is Don from Padlock Technologies. Hopefully this video was informative. I would just play around with the Firewall debug engine here and just see what it does and get yourself familiar with using another technique to figure out, hey, what rules am I hitting or what rules are my traffic hitting in the ACP, right? Once you got that down, this is just another technique, another thing that you can use that rarely anybody really talks about to do your troubleshooting. This is Don from Padlock Technologies. Again, don't forget to share, comment, like, and subscribe. I appreciate you watching. Thank you. Have a nice day.